Welcome students for the chemistry lecture, and I hope you will learn better at your home. Stay safe and keep corona away from you. So let us begin in detail with the one component system, the sulfur system. And before explaining the sulfur system, I will explain you the polymorphism observed in the sulfur. Here poly means many and morph means forms. That means the existence of one solid having two different forms. That phenomenon is called as polymorphism. And the polymorphism observed in a sulfur, it is the we have rhombic sulfur and monoclinic sulfur, and remember that these two solid forms of sulfur, they have the different physical properties, and it is called as enantiotropic because the rhombic sulfur, it is stable below the temperature 95.6 degrees centigrade, and monoclinic sulfur, it is stable up to 120 degree centigrade. These two forms of sulfur, they are interconvertible. That means we can convert rhombic sulfur into monoclinic sulfur as well as the monoclinic sulfur into rhombic sulfur. This is the polymorphism and enantiotropic forms. They are interconvertible. One form it will get converted into another form. And again the temperature at which the rhombic sulfur crystalline form, it will get converted into monoclinic sulfur. That temperature, it is called as transition temperature. And here the polymorphism, it is observed in elements as well as compounds. And remember that the polymorphism observed in case of elements, it is called as allotropy. For example, all of you know the allotropes of carbon, they are diamond, fullerene, graphene or graphite. These are the allotropes of carbon. Here the different forms of sulfur, they are rhombic sulfur and monoclinic sulfur, and polymorphism observed in elements, it is called as allotropy. And these are the two allotropic forms of sulfur, rhombic sulfur and monoclinic sulfur, and they are enantiomers. Enantiomers means one form it will get converted into another form, and the temperature at which the transition of rhombic sulfur takes place into monoclinic sulfur, that temperature it is called as transition temperature. Remember that this is included under the polymorphism. Here we will see in a detail the sulfur system. Here the maximum number of phases that are possible in sulfur system, they are 4 phases. The two solid phases, rhombic sulfur and monoclinic sulfur. Then third phase, here it is liquid sulfur, and fourth phase, here it is sulfur vapor. Then see, all the 4 phases can be represented by only one chemical individual, and that individual is sulfur itself. Hence, it is a one component system, and we can use the phase rule as F, it is equal to C minus P plus 2. and here we can have the F, it is equal to 3 minus P. That means we can find the degree of freedom by putting the value of C as a one component. Here P means number of phases and this 2, that is the two variables. That means 2 plus 1, it becomes equal to 3, and 3 minus number of phases we can put here as 1, 2, 3, 4. We can have the degree of freedom. This is the simple formula which is used in the determination of degrees of freedom in case of the one component system. By using this formula, F it is equal to 3 minus P, we can find the degrees of freedom. Then we will see in detail the phase diagram of the sulfur system. Here, this is the phase diagram of sulfur system. And you know, the phase diagram, it is the diagram of pressure versus temperature. Along this x-axis, we have temperature values. Along this y-axis, we have pressure values. And remember that these pressure and temperature values are not to the scale. Here, this region A, B and E, G. Along the right side of these points, we have solid phase, that is the rhombic sulfur, and it has a stable existence. Then the area enclosed by these points B, E, C. We have another solid, that is the monoclinic sulfur, and along this curve B, E, two phases are in equilibrium. The rhombic sulfur, it is in equilibrium with monoclinic sulfur. And here, this is a transition curve of rhombic sulfur into monoclinic sulfur. And here, this takes place at temperature 95.6 degree centigrade. This rhombic sulfur, it slowly get converted into monoclinic sulfur. Then this third region here, to the right of these points G, E, C and D, we have liquid sulfur. It has stable existence, and this monoclinic sulfur at temperature 120 degree, the monoclinic sulfur melts and it gets converted into liquid sulfur. Then here below these points A, B, C and D, we have sulfur vapor. Here sulfur vapor, it has stable existence. Remember that in the area only single phase it has stable existence. In the phase diagram of sulfur system, there are 4 phases, and in these 4 areas, here we have shown these 4 phases, they have stable existence. And remember that in the phase diagram, areas are bivariant. That means to mention any point in the area, we have to fix pressure and its temperature. Okay. Then we will see the curves. Here this AB curve. Along AB curve we have two phases in equilibrium. Here sulfur rhombic, it is in equilibrium with sulfur vapor, and by application of phase rule, this is the sublimation curve of a rhombic sulfur, and we have the degree of freedom as a 1. Then along this curve B.C. monoclinic sulfur, it is in equilibrium with sulfur vapor. Again this curve, it is a univariant, or degree of freedom is 1. Then along this curve C, D, two phases are in equilibrium. Here sulfur liquid, it is in equilibrium with sulfur vapor. Again, this curve, it is a univariant system. Then along this curve, B, E, two phases are in equilibrium, and that two phases are rhombic sulfur, it is in equilibrium with monoclinic sulfur, and this curve, it is shifted away from the pressure axis. Here, this is the transition curve. Then along this curve CE, two phases are in equilibrium. Monoclinic sulfur, it is in equilibrium with sulfur liquid. This curve, it is also a univariant curve. Then this curve EG, two phases are in equilibrium. Sulfur rhombic, it is in equilibrium with sulfur liquid. And again, this curve is univariant system. Then we will see the triple points in the diagram. And the here, this is a BF curve. It is metastable transition curve of monoclinic sulfur into sulfur vapor. And this is again CF, metastable curve of monoclinic sulfur into sulfur vapor. This is the again along this curve two phases are in equilibrium. Again along this curve also two phases are in equilibrium, and this curve FE, it is a metastable transition curve. That means along this curve two phases are in equilibrium, sulfur rhombic and sulfur monoclinic. The curves which are shown by dotted lines, this one, this one, this one, these are the metastable curves. That means we can have the two phases by careful approach in a one direction only. Then here B point, it is a first transition point having temperature 95.6 degrees centigrade, and along this B point rhombic sulfur, it is in equilibrium with monoclinic sulfur, it is in equilibrium with sulfur vapor, and by the application of phase rule we have degree of freedom, it is equal to 0. That means at this B point we do not have freedom to fix either temperature or pressure or composition here. Then the next triple point, here it is C, and at this C point monoclinic sulfur, sulfur liquid and sulfur vapor are in equilibrium. So this second point, it is a triple point. Then see this E point, this is also a triple point, and along this E point sulfur rhombic, it is in equilibrium with sulfur liquid, it is in equilibrium with monoclinic sulfur. This E point, it is a triple point having degree of freedom is 0, and this F point, along this F point three phases are in equilibrium, rhombic sulfur, here monoclinic sulfur, and here sulfur vapor are in equilibrium. This is the explanation of the sulfur system. Remember the explanation of phase diagram of sulfur system, it means the explanation of the number of areas, in which area which phase it has stable existence, and by application of phase rule you have to calculate F, it is equal to 2 in case of phases. In case of curves F, it is equal to 1, and in case of triple points F, it is equal to 0. And here if the all four phases of sulfur, they can coexist and are in equilibrium, then what happens, the degree of freedom F, it becomes equal to -1, and it is never possible. That means we cannot have the degree of freedom as a -1. So in case of sulfur system, the four phases of sulfur, they never coexist. They are not in equilibrium at the same time. Only maximum 3 phases are in equilibrium. So there may be question as 4 phases of sulfur, they cannot coexist. If all the 4 phases of sulfur they can exist simultaneously, then degrees of freedom F by phase rule equation, it becomes equal to -1, and it is never possible. So all the 4 phases of sulfur they never coexist, or it is not possible. Then here again the curve AB curve, it is called as sublimation curve of rhombic sulfur. The BC curve, it is the sublimation curve of monoclinic sulfur. The CD curve, it is the vapor pressure curve of liquid sulfur. CE curve, it is the fusion curve of monoclinic sulfur. BE curve, it is the transition curve of solid sulfur, and EC curve, it is the fusion curve of rhombic sulfur. At any curve, the phase rule becomes here 3 minus P. Along curve, 2 phases are in equilibrium. Therefore, 3 minus 2, it becomes equal to 1. So, the curves in the phase diagram, they are monovariant or invariant or univariant. Univariant, that means F, it is equal to 1. Then here again this is the phase diagram of sulfur system. It also clearly explains the 4 regions and all these curves. Then see the triple points. Here point B, it is a triple point. Point C, it is also triple point. Point E, it is also a triple point. These are the 3 triple points in the phase diagram. And remember that at any triple point, by using phase rule 3 minus 3, that means it is equal to 0. All triple points are non-variant systems. Then, as already I have explained you, the areas here ABEG, it contains rhombic sulfur. BCEB, it contains monoclinic sulfur. DCEG, it contains sulfur liquid. And the area here below the points ABCD, sulfur vapor has a stable existence. And remember that in an area, the phase rule becomes here 3 minus 1, it is equal to 2. So the areas are bivariant system. Then the metastable equilibrium. Here 3 dashed curves. The curve BF, it is a sublimation curve of metastable rhombic sulfur. CF, vapor pressure curve of supercooled liquid sulfur. The curve FE, fusion curve of metastable rhombic sulfur. And one triple point F here, metastable triple point F. And 3 areas, the area ABFE, metastable rhombic sulfur, the area ABFCD, sulfur vapor metastable state, and here area DCFE, supercooled liquid sulfur. So thank you. For the next lecture, we will see the 2 component system.